Good morning everyone. Today we are going to learn about improper integrals. First we are going to see about definition of beta function. An integral of the form 0 to 1 x power m minus 1 1 minus x the whole power n minus 1 dx, where m greater than 0, n greater than 0, then the integral is known as beta function and it is denoted by beta of m comma n. Here x is a variable. Next we will learn about definition of gamma function. An integral of the form integral 0 to infinity x power n minus 1 e power minus x dx for n greater than 0 is known as gamma function and it is denoted by gamma of n. We are going to first learn about recurrence relation of gamma function. This is an important relation formula which will be useful in solving improper integrals. So let us see the proof. By definition of gamma function, we know that gamma of n equal to integral 0 to infinity x power n minus 1 e power minus x dx. Here n is greater than minus 1. Let us take this as equation number 1. Now if we change n as n plus 1, then we get gamma of n plus 1 is equal to integral 0 to infinity x power n plus 1 minus 1 into e power minus x dx. Here that x power of x, that is n plus 1 minus 1, 1 get cancelled. So this integral becomes integral 0 to infinity x power n e power minus x dx. So let us take this as equation number 2. Now we are going to solve this integral. Now we were aware about the integration of parts rule. In that we have to take u and v, two functions. So let us take u as x power n and dv as e power minus x dx. Then we have to calculate du. What is du? If we differentiate x power n, then we will get n into x power n minus 1 dx. To get v, we have to integrate dv. So if we integrate dv on both sides, then we get v is equal to, we know that the integration of e power minus x is nothing but minus e power minus x. So therefore v is equal to minus of e power minus x. Now we will use the integration by parts rule. What is that? It is that integration u dv is equal to uv minus integral v du. So here u is x power n, v is minus e power minus x. So it will be the first term and here the limits are from 0 to infinity and the next term will be minus of integral v du. So v is nothing but minus e power minus x, we are taking that outside, and du is nothing but n into x power n minus 1 dx. Here n is the constant, so we are taking that also outside. So this will be nothing but gamma of n plus 1 is equal to minus of x power n e power minus x, limits from 0 to infinity, minus of minus n integral 0 to infinity x power n minus 1 e power minus x dx. This can be written as n into integral 0 to infinity x power n minus 1 e power minus x dx. Why? Because if we substitute the upper limit infinity in the first term, we know that whenever x goes to infinity, e power minus x goes to 0. So at infinity the term will vanishes. Next at x equal to 0, the term will become 0. So the second term will be coming. So that is nothing but n into integral 0 to infinity x power n e power minus x dx, which is nothing but n into gamma of n. So gamma of n plus 1 is equal to n into gamma of n. This is the recurrence formula for gamma function. Next we are going to use the recurrence formula to get a formula gamma of n plus 1 equal to n factorial, where n is any positive integer. How will we get this? From the recurrence formula we have gamma of n plus 1 is equal to n into gamma of n. So for n plus 1 we are getting n into gamma of n. So for n minus 1 we will get n minus 1 into gamma of n minus 1. So n into gamma of n will be equal to n into n minus 1 into gamma of n minus 1. Again if we substitute the same process to gamma of n minus 1, we will get n into n minus 1 into n minus 2 into gamma of n minus 2. So proceeding in this way, after some n stage, we will get n into n minus 1 into n minus 2 into n minus 3 and so on, 3 into 2 into 1 into gamma of 1. Now what is this gamma of 1? Let us calculate. So gamma of 1 is nothing but, this is by the definition of gamma function. It is nothing but integral 0 to infinity x power 1 minus 1. That is, the n is nothing but here 1. So x power 1 minus 1 e power minus x dx, which is equal to integral 0 to infinity e power minus x dx. And we know that the integral of e power minus x is minus e power minus x. If we substitute the limit 0 to infinity, for the upper limit it will be 0, for the lower limit it will be 1. So already there are minus sign, and in the formula there is minus sign, so minus into minus plus. So we will get 1. So we will substitute in this recurrence relation, we get gamma of n plus 1 is equal to n into n minus 1 into n minus 2 and so on, 3 into 2 into 1. What is this? This is a famous formula, that is n factorial. So gamma of n plus 1 is nothing but n factorial. Now we can use the same pattern, same procedure to obtain value of gamma of n plus a, where a is an integer. So in the place of n, we are having n plus a. So gamma of n plus a can be viewed as gamma of n plus a plus 1 minus 1. So we have to take that n as n plus a minus 1. The final term will be plus 1. So by using a recurrence formula, we will get n plus a minus 1 into gamma of n plus a minus 1. Again repeat the same process. We will finally get the result as gamma of n plus a equal to n plus a minus 1 into n plus a minus 2 and so on, a into gamma of a. Now we discussed about the recurrence formula of gamma function and its result, that is gamma of n plus 1 equal to n factorial. Now we are going to discuss about the properties of beta function. What are they? There are three properties of beta function. First one is, beta is a symmetric function with respect to the integers m and n. That means beta of m comma n is equal to beta of n comma m. That is, if we interchange the roles of m and n, the integral values does not change. So let us see the proof. So proof of this property is, we know that from the definition of beta function, beta of m comma n is nothing but integral 0 to 1 x power m minus 1 1 minus x whole power n minus 1 dx. Here putting x equal to 1 minus y, then dx will be minus dy and y will be 1 minus x. Now we will see about the limits. The lower limit is 0. When x equal to 0, if we substitute in this x equal to 1 minus y expression, we will get y equal to 1. And if x equal to 1, then we will get y equal to 0. Now we substitute all this in the given beta of m comma n expression, we get beta of m comma n is nothing but integral 0 to 1 x power m minus 1 1 minus x whole power n minus 1 dx, which is equal to, that x is nothing but 1 minus y the whole power m minus 1. 1 minus x is nothing but y. So y power n minus 1. Dx is nothing but minus dy. So we are taking the minus outside because it is a constant. Now we know that there is a famous property of finite integrals. What is that? If we interchange the limits, there will be a minus sign comes out. So therefore minus of integral 1 to 0 1 minus y the whole power m minus 1 into y power n minus 1 dy is nothing but integral 0 to 1 1 minus y the whole power m minus 1 into y power n minus 1 dy is nothing but the same beta function expression. So this is nothing but beta of n comma m. Now let's move on to the next property of beta function. What is that? Beta of m comma n is equal to integral 0 to infinity y power m minus 1 divided by 1 plus y the whole power m plus n into dy. Proof. We know that beta of m comma n is equal to integral 0 to 1 x power m minus 1 into 1 minus x the whole power n minus 1 dx. Here also we are going to use the substitution method. Here what is the substitution? We are going to put x as y divided by 1 plus y. So dx will be, by using u by v method, we will get dy by 1 plus y square. So again we have to calculate the limits. When x equal to 0, y will be 0. When x equal to 1, y will be infinity. If we substitute in the limit, we will get beta of m comma n is equal to integral 0 to 1 x power m minus 1 into n minus 1 minus x the whole power n minus 1 dx, which is nothing but after the substitution integral 0 to 1 y power m minus 1 divided by 1 plus y the whole power m plus n minus 2 into dy by 1 plus y the whole square. So here one denominator we will observe that 1 plus y term is common in two places. So we have to use the formula. What is that formula? A power m into a power n is equal to a power m plus n. Here 1 plus y is that a. So denominator will become 1 plus y the whole power m plus n minus 2 plus 2. 2 will get cancelled. So the final integral will be integral 0 to infinity y power m minus 1 divided by 1 plus y the whole power m plus n into dy. We know that if we have x and y anything, the integrals are same. So now we will go to the third property. It deals about the trigonometric functions. So here the property is beta of m comma n is equal to 2 times integral 0 to pi by 2 sin power 2m minus 1 theta cos power 2n minus 1 theta d theta. So proof of this, we know that beta of m comma n is what? Integral 0 to 1 x power m minus 1 1 minus x the whole power n minus 1 dx. So here we are going to use the substitution method. What is the substitution? Here we are having the trigonometry function. So let us take x equal to sin square theta. We know that there is a famous formula, that is cos square theta plus sin square theta equal to 1. So 1 minus sin square theta will be cos square theta. So 1 minus x will be 1 minus sin square theta, which is equal to cos square theta. Now we have to differentiate x. So if we differentiate x, we will get dx equal to sin square theta. By using the chain rule, we will get 2 into sin theta, and sin theta if we differentiate, we will get cos theta. So dx is nothing but 2 into sin theta cos theta d theta. Now we will calculate the limits. When x equal to 0, sin 0 is 0. So theta is 0, theta should be equal to 0. When x equal to 1, sin theta is 1. So for what values it will be 1? For angle theta equal to pi by 2 only, it will be have value 1. So when x equal to 0, theta equal to 0. When x equal to 1, theta equal to pi by 2. Now the beta of m comma n becomes 2 times, because integral 0 to pi by 2 sin square theta the whole power minus 1 into, in the place of 1 minus x it will be cos square theta. So the whole power n minus 1 into 2 times sin theta cos theta d theta. So we will take the 2 outside. So which is equal to 2 times integral 0 to pi by 2 sin power 2m minus 2 it will come, and already there is a term sin theta. So again using the rule, a power m into a power n is nothing but a power m plus n. So sin power 2m minus 2 plus 1. So sin power 2m minus 1 theta. Similarly cos power 2n minus 1 theta d theta. So beta of m comma n is equal to 2 times integral 0 to pi by 2 sin power 2m minus 1 theta cos power 2n minus 1 theta d theta. Now we are going to see an important relation between beta and gamma function. So it is that beta of m comma n can be represented in terms of beta function as follows. Beta of m comma n is equal to gamma of n into gamma of n divided by gamma of n plus m. So now let us see the proof of this. We know that gamma of n is what? Integral 0 to infinity x power n minus 1 e power minus x dx. First we are going to put x as xz. Here we are treating that z as a positive constant with respect to x. That is x as a variable, z as a constant. So if we substitute in this first integral, we will get gamma of n equal to integral 0 to infinity. Here x will becomes xz the whole power n minus 1. E power minus x becomes e power minus xz. What about dx? Dx is nothing but z is a constant. So xz becomes z into dx. The limits will not change. So it will be 0 to infinity only. Now we will explicitly expand this expression in the integral, that is the integral in the gamma of n expression. Then xz into 1 n power n minus 1 can be written as z power n minus 1 into x power n minus 1 into e power minus xz into z into dx. So now z power n minus z term occur in two places. So z power n minus 1 into 1. So it will become z power n. So x term will be x power n minus 1. Exponential term will be e power minus x z dx. So we are having this term. Now next we are going to do a multiplication on both sides by the term e power minus z into z power m minus 1. If you multiply on both sides, what we will get? Left hand side will be gamma of n into e power minus z into z power m minus 1, which will be equal to integral 0 to infinity. We are taking the term inside the integral. So it will becomes, already there is a term z power n minus 1. Now we multiply by z power m minus 1. So it will be z power m plus n minus 1 into x power n minus 1 into, already there is a term e power minus xz. Now we multiply e power e minus z. So it will becomes e power minus of 1 plus x into z. So the integration will be d with respect to dz and dx. So now we are integrating on both sides with respect to dz. We will get gamma of n into integral 0 to infinity e power minus z into z power m minus 1 into dz, which is equal to integral 0 to infinity double integral. So e power minus of 1 plus x into z into z power m plus n minus 1 into dz into x power n minus 1 dx. Now we will collect the terms of z in one integral, that is integral 0 to infinity e power minus of 1 plus x into z into z power m plus n minus 1 into dz. This is box, but this is nothing but the change of order of integration, because everything in the integrand, exponential, arithmetic function, z are all continuous functions, so we can interchange the order of the integral. So now we can, our concentration is on the integral of 0 to infinity e power minus of 1 plus x into z power m plus n minus 1 into dz. In this term we are going to substitute, that is z into 1 plus x as y, then z will be y into y divided by 1 plus x, then dz will be dy divided by 1 plus x. That is, if we concentrate on z, that x will become a constant with respect to z. So therefore this integral 0 to infinity e power minus of z into 1 plus x into z power m plus n minus 1 dz becomes 1 divided by 1 plus x the whole power m plus n, because x is constant, no, so we are taking it outside. Integral 0 to infinity e power minus y power m plus n minus 1 into dz becomes nothing but dy by that, so which is nothing but dy. So if we observe that the integral is nothing but gamma function, where the integer is nothing but m plus n, so the integral will be gamma of n plus m divided by 1 plus x the whole power m plus n. Now we substitute in the previous expression, then we will get gamma of n, that integral 0 to infinity e power minus z power m minus 1 dz is nothing but gamma of m. So left hand side will be gamma of m into gamma of n, which is equal to right hand side will be gamma of n plus m into integral 0 to infinity x power n minus 1 divided by 1 plus x the whole power m plus n into dx, which is nothing but by the property, second property of beta function, that integral is nothing but beta of m comma n. So gamma of m into gamma of n is equal to gamma of n plus m into beta of m comma n. Hence beta of m comma n is equal to gamma of m into gamma of n divided by gamma of n plus m. So till now we are seeing about the properties and relation between the beta and gamma function. Now we are going to discuss some problems, that is improper, how to solve the improper integrals. So first we need another formula which is very very important in solving improper integrals, that is gamma of 1 by 2. What is the value of gamma of 1 by 2? So it is nothing but root pi. Now we will see the proof of that. So we are going to calculate this gamma of 1 by 2 using the relation between beta and gamma function only. So what is that? We know that beta of m comma n is equal to gamma of m into gamma of n divided by gamma of n plus m. Here gamma of we need gamma of n 1 by 2 value. So now we are substituting m equal to 1 by 2 and n equal to 1 by 2. Then we get beta of 1 by 2 comma 1 by 2 is nothing but gamma of 1 by 2 into gamma of 1 by 2 divided by gamma of 1 by 2 plus 1 by 2, that is nothing but 1. So we know that what is the value of gamma of 1? It is 1. So the numerator becomes gamma of 1 by 2 the whole square, denominator is 1. So beta of 1 by 2 comma 1 by 2 is nothing but gamma of 1 by 2 the whole square. Now we got that expression gamma of 1 by 2 in the right hand side. Now we have to calculate what is beta of 1 by 2 comma 1 by 2. Now let us calculate that. So beta of m comma n is nothing but by property 3. Next 2 times integral 0 to pi by 2 sine of 2 power m minus 1 theta into cos power 2n minus 1 theta d theta. No. So in that we are going to substitute m equal to 1 by 2, n equal to 1 by 2. So we will get beta of 1 by 2 comma 1 by 2 is nothing but 2 times integral 0 to pi by 2 sine power 2 of 2 into in the place of m, if we replace 1 by 2 it will be 2 into 1 by 2 minus 1 into theta cos of 2 into 1 by 2 minus 1 into theta d theta. So we know that 2 into half is nothing but 1 minus 1 is 0. So this integral becomes 2 times integral 0 to pi by 2 sine power 0 theta cos power 0 theta d theta, which is equal to, we know that anything power 0 is 1. So sine 0 theta is 1, cos 0 theta is 1. So it will be 2 times integral 0 to pi by 2 d theta. What is that? If we integrate d theta, it will be theta. If we substitute the limit 0 to pi by 2, it will be pi by 2 minus 0. Outside 2 is common. So 2 into pi by 2. So it will be pi. So if we substitute in the relation between beta and gamma function, we will get gamma of 1 by 2 the whole square is nothing but beta of 1 by 2 comma 1 by 2, which is nothing but pi. So gamma of 1 by 2 the whole square is equal to pi. Hence gamma of 1 by 2 equal to root pi. We always memorize this formula to calculate improper integrals. Now we are going to go to the first problem. Evaluate integral 0 to infinity e power minus x square dx. First, if we are given a problems that is like to solve integral like this, first we have to try to see the limits. Here the limits are 0 to infinity. So somewhat we have to observe that it should be a type of gamma function. So first we try for the gamma function. So for that I am taking a substitution method. Here what is the substitution is I am taking x square, that is in gamma function we will see that the gamma of value is nothing but gamma of n equal to integral 0 to infinity e power minus x power n minus 1 dx. Here in the place of x there will be x square. So we have to remove it. So for that I am taking the substitution as put x square equal to t. Then we know that what is the derivative of x square? It is 2x into dx. So dt is equal to 2 times x into dx. Then what about t? It is nothing but root x. What about x? It will be root of t. So now we substitute in the given integral. We will get integral 0 to infinity e power minus x square dx is equal to, the limits will be same. Because if x equal to 0, t will be 0. If x equal to infinity, t will be infinity. So which is equal to integral 0 to infinity e power minus x square becomes e power minus t. Dx becomes 2 dt divided by 2x. But what is x? It is root t. So e power minus t into 1 by 2 into root t into dt. So we take the 1 by 2 constant outside. So 1 by 2 times integral 0 to infinity e power minus t into root of t in the denominator. If you take numerator, it will become t power minus 1 by 2 into dt. Now we have to observe that what is the minus 1 by 2? That minus 1 by 2 is nothing but half minus 1. So this expression is nothing but gamma of half integral. So this is equal to 1 by 2 times gamma of 1 by 2. Just before we proved that gamma of 1 by 2 is root pi. So this value is nothing, the value of the integral is nothing but root pi by 2. Next we will solve problem which involves beta function. So evaluate integral 0 to 1 x power 7 1 minus x the whole power 8 dx. So first we know that this is a type of beta function. So what is beta function? Integral 0 to 1 x power m minus 1 1 minus x the whole power n minus 1 dx. So here in the place of m minus 1, what is the value? 7. So m minus 1 equal to 7, n minus 1 equal to 8. So we know that the relation between the beta and gamma function. What is that? Again one more time I am repeating the same relation, that is beta of m comma n is equal to gamma of m into gamma of n divided by gamma of n plus m. So thus the given integral is nothing but beta times 8 comma 9, because that integral is nothing but beta of m comma n. That m is nothing but 8 because m minus 1 equal to 7, no. So m is equal to 7 plus 1, 8. N minus 1 equal to 8. So n is equal to 9. So this integral 0 to 1 x power 7 into 1 minus x the whole power 8 into dx is nothing but beta of 8 comma 9. If we substitute in the relation between beta and gamma function, we will get gamma of 8 into gamma of 9 divided by gamma of 8 plus 9. So here we are going to use the recurrence relation, that is gamma of n plus 1 equal to n factorial. So gamma of 8 will be 8 can be written as 7 plus 1. So gamma of 8 will be 7 factorial, gamma of 9 will be 8 factorial. In denominator, gamma of 8 plus 9 is gamma of 17. So 17 before number is 16, so 16 factorial. So 7 factorial into 8 factorial is 16 factorial. If we calculate this, 7 factorial is nothing but 1 into 2 into 3 up to 7. 8 factorial is 1 into 2 into up to 8. In the denominator it will be 1 into 2 into 3 up to 16. If we get cancel something, we will get some more finite answer. So next we will go to the next problem. That is, let us evaluate integral 0 to pi by 2 sin power 5 theta cos power 3 theta d theta. So the solution, we know that by the property 3 of beta function, beta of m comma n is equal to 2 times integral 0 to pi by 2 sin power 2m minus 1 theta into cos power 2n minus 1 into theta d theta. Let us compare this with the given problem. So we will observe that there is 2 absent and in the place of 2m minus 1 there is 5. In the place of 2n minus 1 there is 3. So let us compare this. So we will get 2 power m minus 1 is equal to next 2 power m minus 1 equal to 5, 2 power n minus 1 equal to 3. So if we calculate this, then m will be 5 plus 1 by 2, that is 6 by 2, 3, and n will be 3 plus 1 by 2, that is 4 by 2, 2. If we substitute in this integral, we will get integral 0 to pi by 2 sin power 5 theta cos power 3 theta d theta is equal to beta of 3 by 3 comma 2 divided by 2. So again using the relation between beta and gamma function, we get 1 by 2 times gamma of 3 into gamma of 2 divided by gamma of 3 plus 2. What is gamma of 3? 2 factorial. Gamma of 2? 1 factorial. 3 plus 2 is 5. That is 4 factorial, which is equal to 2 by 24. Before that 1 by 2. So 2 cancel. So 1 by 24.